This is a good example of the relationship between solubility and the KSP. So notice that the KSP is not the same thing as the salt's solubility. The KSP is not the same thing as the solubility of the salt. They're related, but they're not the same thing. And hopefully this table kind of shows the relationship between the KSP and the solubility. They're related, but they're not the same thing. Okay.
Okay.
All right, so let's try to get to the quantitative problems. So what are the main types of problems you're going to see? Can I erase this table now? So here's the main types of problems you're going to see. Some problems will tell you the solubility, and then they will ask you to figure out the KSP from that. That's a very common type of problem where they tell you the solubility and they ask you to figure out the KSP. And there's a second type of problem. The second type of problem tells you the KSP and asks you to figure out the solubility. So we have to be able to go in either direction. If we're given the solubility, we should be able to find the KSP. And if we're given the KSP, we should be able to find the solubility.
So these are two types of
the two main types of problems you can expect to see on the test.
Okay.
So now let me give you a method for solving these types of problems. So here's the method. Step one. Step one, saturate the solution. Well, maybe I should say, maybe the real step one is to write the chemical equation in ice table. And once you've got your ice table, step two is to saturate. The solution. Then step three is to set the Q equal to the KSP. Why is that legal? Because when you've saturated the solution, Q is equal to the KSP, as we saw from that previous table. The table told us that when the solution is saturated, Q equals KSP. And once you have an equation, you can solve the equation for the unknowns. Okay. So you set this up, and then you solve the equation for whatever the unknown is. So that's our three-step method, and we can use that for most of the types of problems that we're going to be dealing with in this chapter. What do I mean by saturate the solution? Well, how much of the salt do you need to add to saturate the solution? You have to add the solubility.
Okay.
So you can use the solubility to see how much you need to add to saturate the solution. So let's try to get to a problem. So let's try this. Okay, so let's say that lead fluoride has a solubility of 0.64 grams per liter at 298 Kelvin. And the question is to figure out the KSP at 298 Kelvin. So we'll mainly go through this together.
So we need to write down the first equation.
That's right.
So PEF2 plus F minus 2
That's a good start. We know that fluorine is in the next to last column, so it has a -1 charge. So the lead has to have a +2 charge to balance the fluorines. That's good. And it's good that you saw that there would be 2 fluorides on the right because of this subscript. Now you have your ice table. All right, this next step is kind of hard.
Because this is a gram in liters, so we need to convert grams per liters into molar.
Okay, that's good. I'm glad that you noticed that. That's the hard thing, is to notice that. We can't put grams into the ICE tables. We discussed that these don't work for grams. So you're right, we need to change that.
64 grams per liter multiplied. Do you know it's we need to figure out the atomic mass of the.
Do you have your, here's your book. Back.
So, thank you. So it's we can just use as a molar molarity.
Good.
Because
Good.
moles per liter is a.
That's a really good conversion. Okay, so what are our target units here? Our target units were moles of lead fluoride per liter. So we needed to get rid of the grams. So to go from grams to mole, you use the molar mass. So what this was 207.2 plus 2 times 19 from the periodic table. That gives you 245.2 molar mass. Then we did 0.64 divided by 245.2. What did you get for that?
156.928. Is it right? I think no, I won't. Instead of I should have divided 0.6.
Oh yeah, after all your great work setting it up, yeah, you made a mistake. Okay, that was a good setup.
It just rushed.
There you go. Okay. Right, 0.0026
So
molar.
now we can plug,
Mm-hmm.
put in a change.
Yeah.
Minus. And then this is going to be, because it's a 1
Mm-hmm.
per 1, it's going to be plus 2, 6.
Great.
And this is going to be plus 2.
Good.
I can't do that.
Mm-hmm.
Okay.
Great.
And it's
Great. Okay. There's only one thing that we can do to make that a little bit more elegant. What we should have done first is put in numbers for the initial row. So what number should I put in here for this initial amount?
0.0026.
Yeah, remember that's what it means to saturate the solution. How are we going to saturate the solution? We're going to saturate the solution by starting with an amount of salt that's equal to the solubility. So maybe we can add that to our method. How do you saturate the solution? You usually saturate the solution by starting with an amount of the salt that is equal to the solubility. So we need to start with an amount of the salt here that is equal to the solubility. And now this is in molars, so we can put it in the table. So step 2, saturate the solution, and you usually do that by starting initially with an amount of salt that is equal to the solubility. We know that's the amount we need to add to saturate the solution.
By starting the amount of.
Saturate the solution by starting with an amount of salt
Okay.
that is equal to the solubility of the salt.
Okay.
And that should make sense.
Yeah.
And that's what you were doing here. That's what you had figured out to do.
That is equal to the solubility.
How do we saturate the solution? By starting initially with an amount of salt that's equal to the solubility, and it's our job to put in that right number here. Good. By the way, before I forget, what is this called that they gave us? This is called the gram solubility of the salt, and what we figured out is the molar solubility of the salt. So there's really two different types of solubility. There's molar solubility and there's gram solubility.
Okay.
Or we could call this the max solubility. So here we have the gram solubility and the molar solubility. So there's two different types of solubility, but which type of solubility can you put into your ice table? You can only put the molar solubility into the ice table. So if they give you the gram solubility, it was good that you figured out that you had to make that into the molar solubility, and you figured out how to do that.